Hello everybody, my name is Eli. Welcome to my YouTube channel. And what we're going to be doing in today's video is we're going to upgrade my Harbor Freight lathe. Now I've had this lathe for about 6 years. That's what I got my start on. My wife bought it for me for my birthday a while ago. And the whole point of this is that I want to make sure that I can keep this lathe running and moving and personalize it and make it more specific to me and what I want. I did build a new shop, which I'm standing in right now, and I bought a Powermatic lathe. So I put the time, effort, and money into a bottom of the barrel, cheap Harbor Freight lathe. Well, as I said before, all my projects up to this point have been done on that lathe. I have a sentimental attachment to it. So I want to invest the money and keep this lathe going and make it mine. Most of the tools that I find most fascinating and impressive are the tools that people have modified or changed over the years to do specific tasks or to fit the needs of the person that are using it. I mean, tools in all reality are there to help you do tasks, so you might as well modify them and change them to what your likings or what your needs are. So I'm not worried about investing the money into this thing. Now, as far as cost for this entire project, I just finished it, and this is kind of the introduction video that I'm doing kind of after the fact, so I can tell you a few things. Number one, it cost me about $450 to upgrade my lathe. However, this entire project could actually be done for about $150 to $200 if you're frugal and if you have certain things. There are a lot of videos out there on YouTube of people adding treadmill motors to a lathe. If you have a treadmill running around, that's fine. I didn't have one, and I wanted to kind of make my motor a little more versatile, so I purchased a motor which cost about $100. And the big expense was I had to buy a variable frequency drive, which cost about $350. So everything else was basically free or I had laying around. If you can reduce the cost of the motor and eliminate the variable frequency drive, then you're saving yourself a lot of money. But we're going to get into that in the actual video. If you're looking for a new lathe, don't run out and buy a Harbor Freight lathe and then tear it apart and do what I did. However, if you do have a Harbor Freight lathe and you want to upgrade, this is not necessarily a bad idea if you don't have a lot of money. What you can do is you can start planning ahead and you can slowly buy the parts over a course of time. And once you have all the parts accumulated, then you can do the upgrade. If you're going to do this to do what I'm doing, where you have a sentimental attachment to it, then it doesn't matter. Spend what you want on it. If you're just trying to stay in the game and keep your lathe running, there are really cheap options for this, such as, like I said, a treadmill motor. You can scour eBay, you can scour Craigslist. You will find electric motors on there for very cheap. I have had a lot of luck finding electric motors on eBay and Craigslist, some as cheap as 50 bucks for a 2-horsepower motor. But there's a lot you have to learn when it comes to that kind of thing. You have to look at the RPMs. Is it 3-phase? Is it a capacitor start? Is it a magnetic field? You know, all those things. So do your research. But anyways, so we're going to go ahead and start tearing this lathe apart, and I'm going to simplify it as much as possible for you. There's a lot of videos out there, and if you're actually thinking about going down the road of modifying your lathe like this, then I'm going to assume that you're somewhat technically capable. So I'm going to skip a lot of the smaller parts because there's so many videos out there on the internals of the Harbor Freight lathe. I don't want to be redundant on anything. And what I'm doing is very case specific to myself. I'm building it for me, and what you want to do may be completely different than what I'm about to do. So I'm just giving you ideas, and I'm showing you my process, and we're going to go through all that, and we'll see how it comes out. Okay, so I'm going to start this video at this stage of the project because there's a lot of information on the internals of this machine out there, and if you're going to go down this road, you're probably already familiar with all the internals. And because I'm not using any of the factory internals, I can just kind of eliminate that portion of the video here. Essentially what I did was I took everything out of it. Like literally everything. If you take a look at it, we'll pop it off of here. You can see there's no electric, the speed control arm's gone, all the pulleys, all the springs, all the bolts, everything. It's just, I threw it in the trash. I don't need it anymore. It's not going to do me any good. I replaced the main bearing here and the one in the front, the two bearings. If you're going to replace them both at the same time. I did replace them with a much higher quality set of bearings than what comes with the machine. So that's been done. So with the original housing, the only thing that I am keeping is the shaft. That's it. I ditched, like I said, I even ditched the bearings. So let me put this back in place. What I'm going to end up doing is I'm going to weld this thing down. I'm going to weld that corner. There's a corner here and a corner there, so that's 4 corners. I'm also going to weld this pin here. I'm going to weld it to the plate, and I'm going to weld the pin shut here. And I'm going to make sure it's a good solid weld so it's not going to go anywhere. This is no longer going to be a swivel head machine. If I was going to do that, I would have to mount the motor here. But the motor that I'm going to use is too big to mount there. It would come out too far, and it would kind of impede anything you were turning here. The only addition to this machine that I have made at this point is this plate. And because this head is no longer going to swivel, I just screwed it to the, well, bolted to the end here. There's 4 bolts that are going to hold it down. This piece is a 1/4 inch thick steel. I think I only paid 12 or 13 bucks for it down at the metal yard. You could use angle iron here instead of a plate. You can get creative with whatever motor you're going to mount. So this is what works for me. That's why I did this. What I have to do now is put the pulley on here. So I'm going to go ahead and grab that, and then we'll take a look at it and explain what I'm going to do. So this is the pulley that I'm going to be using on my lathe. It's an aluminum pulley, and the reason that I ordered this pulley was because all the other pulleys that I found online, the shaft portion, I couldn't find anything that was the right size. I think it's 34 millimeters. I'm not 100% sure. I can't remember. But so I found this one, and I had found some other ones that were only a single pulley, but the issue was they were coming from China, and it would have literally taken them months to get here. So I didn't want to wait months, so I bought this guy. Now this one does not fit in there. It won't. It's just too big. So what I'm going to end up doing is I'm going to take it to the bandsaw, and I think I'm going to cut it down to this pulley, and then I'm going to go ahead and put it onto the shaft, and then we'll move on from there. So I'm not going to film me cutting it or anything, but I will cut it and then come back and we'll take a look at it. The other thing that I have to do is, you see these Harbor Freight keys right here, the key lock, it's not a standard size. Typically I think they're 1/4 inch, but this one is only like 3/16 or something. So this one is obviously larger, and there's no holes drilled here for set screws. So the other thing that I have to do is I'm going to drill a hole through this, probably through this section, not through this section, and I'm going to tap a set screw in there. I might even do 2, I don't know, because the key that's in here is much smaller on here than here, so it's not really going to do much of anything. So I have to put set screws in there. So I'm going to go ahead and cut this down, drill and tap it, and then we'll come back and look at it. Okay, so here we are. I cut the excess off of the pulley with my bandsaw. It was real quick and easy. It's just aluminum, so it cuts really well. After I cut the excess off, I drilled 2 holes, one there and one directly across from it, and then I tapped them so that I can add the set screws, which I've got right here. And these set screws need to be able to grab onto something. So over here I have drilled a hole here and a hole here, which the set screws will go into, and that'll give it the grab that it needs, since my locking key isn't quite the right size. So the other issue that I have right now, and it's not even really an issue, is I have measured them, and this doesn't seem like it goes on there, but checking with my calipers, they are exactly the same size. So it's a very tight fit. You don't want to go beating this thing on here with a hammer or a rubber mallet, because you're going to mar up the inside. It might go on crooked, whatever. And it's aluminum, so it can get messed up really easy. So the solution to that is you want to heat this up with a torch, because this will expand, giving you just enough room to slide it over there, and then it'll shrink on there. So I can't do that with the camera on. I've got to put my welding gloves on and go to it. So I'm going to go ahead and get all that set, and then we'll come back and take a look at it. So I've got everything kind of mounted and put where I want it to be. What I did here is on the plate, I set the motor. Unfortunately, I can't really film and do the work at the same time, so I just have to kind of do it and then explain exactly what it is that I did. So I set the motor on my plate here. I lined my pulley up, and then I marked my cuts here. Now on the bottom of the motor, there's elongated slots here. So I basically drilled the holes in the center of the elongated slot, because I want to be able to loosen these bolts up and move the motor either this way or this way. That way to take the belt off, that way to tighten the belt. So if you put them tight to one side, you're kind of screwing yourself basically. So I set it up, I tightened it down, then I put my pulley on, locked all that into place. This one actually does have the key and the locking screw there, so I took care of all that, and everything's lined up and working the way that it's supposed to be. So let's talk about the motor real quick. This is a 2 horsepower motor. It's a 3-phase motor, and it's essentially, if you look at the specs on this motor and the specs on my Powermatic 3420C, they're almost identical. Very similar motors. I think the one on my Powermatic is a single phase. This is a 3-phase. I think that's the only difference. So essentially what I'm doing with this thing is I'm taking a Hyundai and putting a Lamborghini engine in it. So that's basically what's happening here. So let's talk about the motors. I've got these 3 motors here also. That motor in the center, I bought to make a disc sander out of. That's a 220 3-phase, but the RPMs were too low. It's only about 1700 RPMs. That one there is the one that came off of the Harbor Freight lathe, and it's burned. I don't think the motor's actually burned. Usually on these types of motors, what happens is it's a capacitor start motor, and the capacitor burned out. That motor over there is the one that I actually bought to put on my Harbor Freight lathe, and I was going to do the same setup with that motor as I did with this motor, but I changed my mind on it. That's also a 220 single phase motor, but it's a capacitor start motor. Those motors are harder to get a variable speed on with a controller versus a motor like this, which is a brushless motor, and it runs on a magnetic field. So what you need to do to get the to be able to adjust the speed is you need one of these guys here, and this, we'll pull up into it, is a frequency inverter, and I'll show you the side of it and you'll see the specs here real quick. What this thing does, if you look at it, you'll see right there the input power, 1 phase, 120 volts AC. That's what goes into it. If you look at the output, 1 phase, one phase or 3 phase, 220 volts comes out of it. So this is actually a very handy device to have, and I actually have several of them. There's another one. But what this one does is this takes a 220 volt and single phase and converts that 220 single phase into 220 3-phase. And this one has some options that the other one doesn't. If you look right here and you wire it up correctly, you can go forward or reverse with your motor. Unfortunately, I was not able to find one that would allow 120 volts in and 220 out that had the reverse option on it. I use these a lot in my home shop and my other shop because it's 3-phase is kind of hard to get in a residential area. So if you buy a table saw and you only have 220 volt single phase, but you need 3-phase, you can buy one of these and it'll convert the single phase into 3-phase. This one here was about $98. These are actually fairly cheap, and I have 4 or 5 of these. I actually specifically brought this one home to show you guys, and I will be using this on my table saw when I buy it. This right here I brought home to show you as well. This is essentially a dimmer switch, and this is used on motors that have brushes on them. These are for brushless motors. These will not work on the brushless motors like that one or the one that I have on my lathe, because these work on a magnetic field, which in order to change the speed you need to change the frequency and not the voltage going into it. If you were to put this on 220 volt and use that, all you're doing is cutting the current to the motor. So let's just say you turn this all the way down, this motor's still going to spin. I think it's at 1700 RPMs. No matter what the current is going in there, it's going to spin at 1700 RPMs. Even if you turn it down to 100 volts, it's going to spin at 1700 RPMs, because the frequency is what controls the motor, not the electric current. The only thing that you're going to end up doing is cutting the power on this, and you would be able to stop the motor very easy. You're not going to have any torque, you're not going to have any power. So what you need to be able to do is change the frequency in hertz that changes the magnetic field, which speeds up or slows down the motor. So let me show you how this works. This thing is actually plugged into 120 volts. You can see it's wired there. And I do need to do a little bit of extra on here. I've got to figure out how to mount it in this area. It's going to sit on the front. But anyways, let me fire this thing up and show you how it works. Now, I have not done all the settings on this. This is programmable, so I need to kind of program it to match this motor. And another thing about this drive here, a drive that goes from 120 volts to 220 volts is not cheap. This one here was about $350. Considering that a Harbor Freight lathe is about $350 to $400, it's kind of pointless to buy one of these. Unless you're doing what I'm doing, which I explained at the beginning of the video. So there's a reason why I made this investment. So before I show you how this works, let's talk about the cost of the motors here. This motor was, with shipping, under $100. I bought this motor probably about 4 years ago, and this one had a specific purpose, which I just have not gotten to yet. Typically what happens if I have an idea for a tool like this one, I was going to use on a 2" by 72" grinding belt for making knives and stuff like that. I've just been so swamped I haven't gotten to it, so it was just sitting there. So this one was, like I said, under $100 shipped. This is a Dayton motor. The one in the center is a Dayton motor. This one I bought to make a disc sander, and again, the RPMs were too low to attach it to this. And I paid under $100 for that. I actually think I paid about $70 for that. I found it on eBay. This one I found, believe it or not, on Craigslist. That one I specifically bought for this lathe, but I'm going to end up using it for another project down the road. I didn't want the capacitor start motor because the capacitors tend to burn out easy and it's hard to control. So when I got it in, I was like, you know what, I really don't want to use that motor. I'm going to go use the motor that I already have. The other thing that I like about this motor is it's completely encased. It has a cooling fan in the back, but there is no way for dust to get in there. This is actually typically used in oil fields and stuff like that. It's a pump motor, but it's a 2 horsepower. It's got a lot of torque to it. The thing about this motor, and one of the reasons why I didn't want to use it, is if I flip it up and you look at the back, you can see right into the windings, right into the coil there. And on a lathe, I just don't know if that's a good idea to be getting all that dusty and junky in there. It's just probably not good for the machine. So I kind of opted not to go with that one. And this Dayton motor is the same thing. You can see the coils in there. It's not an enclosed motor. So I just figured that for this application, I would prefer to have an enclosed motor. So that's really why I went with this guy. So let me show you how this thing works. Again, I'm plugged into 110 volt. This is a 3-phase motor. It's wired for low voltage 3-phase. I'm gonna go ahead and press the run button here. I kind of pull back so you can see everything. Now, what happens is this little knob here, this actually changes the frequency in hertz. And I'll show you on the screen here. As you kind of pull it up, it'll give you a reading, and this is the hertz that are going into the motor. And as you turn it up, you're controlling the speed. You can see that number up there changing. So I'm up to about 24 hertz. Up to about 40, 45. Now I'm up to 50 hertz. So right now at this point it's spinning at its max RPM. I'm going to go ahead and turn it down. Let it get all the way down, and then I'm going to turn it off. Okay, so that's basically the hookup for the motor. Now I still need to do a lot of stuff over here, make a cover plate so nothing's getting bound up in here, but essentially at this point I could actually put a chuck on there and go to work and make something. Basically all that's left at this point is to tidy it up, do all the nice looking stuff and make it look good. So I'm going to go ahead and work on that. Now what I'm doing here is very case specific for what I want to do. So if you're going to go ahead and take a Harbor Freight lathe and convert it into something like this, you're kind of going to have to figure out a lot of stuff on your own. And the reason why I say that is you may not end up with the exact same motor that I got. You may want to you may want to make the head turn, so you may want to mount your motor onto the head there. There's so many options that when you're upgrading something like this, a lot of it is going to be completely and totally up to what fits your needs as a person. So what I'm just showing you here is what fits my needs and what I wanted to do, and to maybe give you a couple of ideas and go over a few things. This frequency drive that I got here, it came from ATO is the name of the company. You can look it up. They sell all kinds of frequency drives. This is one of their more expensive ones because, again, it's kind of hard to find anything that goes from 110 volt to 220. So I'm going to go ahead and work on getting this thing tidied up, and then we'll take a look at it then.